This here is a graphite pad, and this is meant to replace the thermal interface material, the TIM, the thermal material between your CPU or GPU and the copper or aluminum heatsink that helps the two mating surfaces come together and keeps your hardware cool. And this fancy little devil right here is ultimately going to be replacing your liquid metal, which is cream of the crop when it comes to your thermal interface material, without any of the spillage. It's very easy to apply this thing. There's no bonding material, there's no adhesive. You literally just take your scissors, cut it to fit the die, set it on the die, put your heatsink on it, and your job is done. But there's a issue with this and laptops, and this is what I want to cover today, and this is very, very important. So I have put this here, or one just like it as I had cut it from this batch, on the Dell G3, the Acer Predator G5, and the Xiaomi Notebook Pro that we have apart in today's lesson. So with that said, let's start off with the issue and why this might not be the right solution for the laptop. You see, most laptop coolers have a cooler that covers both the GPU and the CPU both. And there is never a perfect fit and finish fitment here when it comes to this. If there's just the slightest little twist when this thing is mounted, heaven forbid the CPU side may be a little bit taller than the GPU side, maybe there's a slightly warped motherboard, all things that you're not going to be able to see with the naked eye. And when you go ahead and place this paper thin thermal graphite pad on there, what'll happen is you're going to have some core uniformity issues, meaning on a 4-core chip you might have one that runs extremely cool, another one that's running a little hotter than what it used to, and two that are just pegging T-junction, right? They're hitting 100 degrees Celsius. So in case of the G3, there was definitely some fitment issues, and on idle, I had 3 cores that were hitting 100 degrees Celsius, and the other one was hitting 97, and that was on idle. So what you can do is sometimes you can massage these pieces of copper as they do have some flex, and I was unable to be successful on the G3 to make the graphite pad work. But on the G5, I took this heatsink off 8 times, and I finally got it to work correctly. But with that said, it really did not offer a whole lot better temperatures over Thermo Grizzly's Cryonaut, which is some of the best non-conductive paste out there. It did decrease the actual decibels the machine made, so it was super quiet, but nonetheless, it was a great deal of work in order to get it to work correctly. And in this case, with the Xiaomi, it has excellent uniformity, and heatsink over the dies of the GPU and the CPU are fantastic, and it does do a decent job there as well, but not without a little bit of work with that. There was a little bit of movement and flex that I had to apply on this. Thankfully, this being the CPU side, there are 4 screws, so you have good symmetry and distribution. And then, of course, in the GPU, you have 2. Most of the time, if you're going to apply something like this, it's the CPU that needs the work, but in this case, you're more than welcome to apply it to the GPU as well. This is a great product, but 9 times out of 10, if you put this on your laptop just as you're going to replace your normal thermal paste, your results are going to be far more poor than they ever were even at stock, and that is because of that uniformity issues that you're going to have. This is a very thin material. So in instances where it does work well is when you have a GPU, for example, that is not sharing its heatsink with something else. So the actual copper plating could mount itself perfectly symmetrical, ideally, on the actual die, such as a graphics card here. You have 4 screws, this is one gigantic piece of copper, and it's going over the die, and you can actually tweak the screws and get this thing to fit just right, and you're going to have to do this, as this is a very paper-thin-like material. So perfection and tuning is key to getting the most out of it, but it works excellent on most graphics cards, especially ones with gigantic dies like this old 400 series from NVIDIA. Now, if you can't tell by now, I do have a thing for copper. This is nearly 3 pounds here. This is an all copper heatsink, very old, but the same thing applies. We have a single heatsink platform here that will be mounted to the CPU, and doing the mounting solution and the screws, I can actually get this thing to sit perfectly symmetrical on the die, making that graphite pad a viable solution. So ultimately it works like this. If your laptop has a separate heatsink from the GPU and the CPU, you might be able to get some mileage out of this graphite pad. It could work very well for you. But 99 out of 100 laptops, whether they are gaming laptops, business laptops, you name it, the most common solution is to have your GPU and your CPU die in one gigantic piece of copper that's going to cover both of them. And you're probably going to have some fit and finish issues, whether you realize it or not, and where that regular non-conductive thermal paste comes into play like an icy diamond that's very thick, as it kind of fills in those voids, making contact and core uniformity and just ultimate temperature improvement because it's a thicker material. This graphite pad works really well, provided you have a perfectly symmetrical solution. And as I said before, on that Acer Predator G5, I tore that heatsink off 8 times and just slowly kept tweaking it and bending it until it was perfect. And after all that work that spent maybe 2 hours doing this, probably more, because every time I had to turn on the machine and check thermal performance, it really didn't yield that good of results on that machine, okay? And herein lies a whole nother problem, right? You could put the best thermal interface material in the world on a laptop and you might not actually get better temperatures. And the reason being is because the fan curve is going to scale very closely to the temperature. So what you have done was just delayed the inevitable, and that might be, 80 or 90 degrees Celsius. Which means, what did you do here? Well, you might not have necessarily wasted your time. You probably just made the laptop a little bit more quiet for an extended period of time until it eventually hit that 90-degree threshold or whatever the manufacturer decided to set in their BIOS. So hopefully this makes sense to you. For me, I would recommend staying away from these graphite pads, not because I don't think they're great. It is an awesome product, but the issue is just they're not that good for most laptops because of the way the heatsink is mating to the actual die. So hopefully that makes sense. Hopefully you enjoyed this video. Please feel free to leave comments in the comment section below. And this is Bob of All Trades. Peace out.